This is a multiple-choice question about using SIMPLEARN, SIMPLEIMPUTER to fill in missing values in a dataset. I'll explain how each choice handles the problem. This sets up the problem. We have missing ages, NaN, and I need to use SIMPLEIMPUTER to replace them with the average age. The question asks which code snippets correctly do this. This code imports SIMPLEIMPUTER and creates an imputer object. I set missing values to NaN, not a number, and the strategy to use the mean. Then, I fit the imputer to the age column and transform it to replace the missing values with the mean. I am using a data frame here. This is one valid solution. Here, I'm using SIMPLEIMPUTER again, but this time I am directly working with a NumPy array. I reshape the age column into a 2D array because SIMPLEIMPUTER needs this format. The result is the same. This is similar to option A, but I omit specifying missing underscore values . That's okay because NaN is the default for missing values, so this works too. Similar to option B, I'm using a NumPy array but I explicitly specify the missing values as NaN. Again, this produces the same results. This problem statement sets the stage. We're going to use the SimpleImputer from scikit-learn, a powerful tool for handling missing data, specifically focusing on how to fill in missing age values using the average of the existing ones. This line shows one way to solve the problem. I'm taking the age column from the data frame, converting it into a NumPy array using values, reshaping it into a column vector using reshape -1, 1, meaning it creates a 2D array where the number of rows is automatically determined and the number of columns is 1. Then, I use imp.fit_transform to calculate the mean from the non-missing age values and replace the missing values with that mean. Finally, I assign the result back to the age column of the data frame. This line offers a slightly different way, but it achieves the same result. I'm doing essentially the same thing here, but using slightly shorter code by directly accessing the age column's values through df age. Notice the similarity and subtle differences between this and option B. The fundamental steps are identical, the data reshaping and imputation. Here's another solution that works very well. I obtain a data frame containing only the age column using "df age", ensuring that SimpleImputer receives a 2D array as input, directly applying "fit_transform". This is identical to option A, demonstrating different, but equally effective, syntax. See, multiple paths lead to the same outcome in data science. These choices highlight the flexibility of data manipulation using pandas and scikit-learn. This code snippet shows 1. Way to use scikit-learn's "SimpleImputer". I'm importing the "SimpleImputer" class. I then create an imputer object, setting it to replace missing values, "np.nan", which stands for not a number, with the mean of the column. I'm explicitly telling the imputer what values to consider missing. Finally, I fit the imputer to the age column, reshaped as a data frame using "df age", to meet the 2D array requirement, and transform it, directly updating the age column in your data frame. This is a code sample, part of option A. This line is not a complete, runnable line of code. This shows how we create and configure the imputer object. It's the second line of option A. Here, I'm also using "SimpleImputer" to calculate the mean and replace the missing values. Notice that I do not explicitly specify "missing underscore values". "SimpleImputer" defaults to replacing "np.nan". However, this time, I'm reshaping the input array explicitly using "values", reshape -1, 1, The "-1" in "reshape -1, 1" means figure out the number of rows automatically, and "1" sets the number of columns to 1, ensuring a 2D array. This is similar to line 4, it is the second line of code in option B. Here is yet another way to accomplish the same task. I set the strategy to mean, but I don't explicitly define missing underscore values . Because it's not defined, the SimpleImputer will use the default missing value, which is np.nan . The input data, df, age, as a pandas data frame which is already a 2D array, so no explicit reshaping is necessary. This is similar to lines 4 and 6. This is the second line of code of option C. In this final option, I'm explicitly setting the missing underscore values parameter to np.nan and the imputation strategy to the mean. The input data is explicitly converted to a numpy array using values and reshaped using reshape -1 1 before imputation. This is similar to lines 4, 6, and 8. This is the second line of code of option D. This question asks you to choose the correct code snippets that use scikit-learn's SimpleImputer to fill in missing age values in a dataset using the average of the existing age values. It tests your understanding of how to use SimpleImputer and properly format the data for it. Let's dive in. This line sets the stage. We are tackling a common data science problem, dealing with missing values. Specifically, we'll use the SimpleImputer from scikit-learn, a powerful tool for this task. It's all about cleaning up our data before analysis. This option shows one way to perform the imputation. I create a SimpleImputer object, explicitly setting missing values to nan, not a number, and choosing the mean strategy. Then, I apply the fit_transform method to the age column, using df, age, to maintain it as a data frame, replacing missing values with the calculated mean. It's clean and efficient. Here's another correct approach. I again create a SimpleImputer, but this time I don't explicitly define missing underscore values because nan is the default. To make sure the imputer works correctly, I explicitly reshape the age column into a 2D array using values reshape -1 1 before using fit_transform . It's another valid way to achieve the goal. This method is similar to option A, but simpler. I set the strategy to mean, without explicitly defining missing underscore values . It works because SimpleImputer defaults to nan for missing values. Notice that I'm still feeding it a properly formatted data frame. This is quite similar to option B. I explicitly set missing underscore values to nan, just like in option A, but use the more concise way to access the column's values and reshape the data into a 2D array. SimpleImputer happily accepts this input, and the result is the same. All the options A, B, C, and D are correct ways to use SimpleImputer to handle missing values in the age column. The differences are mainly in the way the data is formatted and the explicit setting of parameters. Each of them produces the correct imputation using the mean. This illustrates the flexibility in using SimpleImputer. This title introduces the topic. We'll learn how to use a tool called SimpleImputer from the scikit-learn library in Python to fix missing data. It's a common problem in data science. This tells you that you will be answering a multiple-choice question, testing your knowledge of SimpleImputer . Get ready to put your skills to the test. This is the core question. We are given a dataset with missing ages and need to choose the correct code to fill them using the average age. Nan stands for, not a number, a common way to represent missing data. This code uses SimpleImputer to fill missing values. I import the necessary function, set missing values to nan, specify the strategy, mean, to use the average, and then apply it to the age column of a data frame. It's option A. This is option C. It's similar to option A but omits explicitly defining missing underscore values . Because nan is the default, this works perfectly fine. This is option D. I use SimpleImputer similarly to option A, but the data frame column is reshaped into a 2D array using values reshape -1 1 before imputation. This is another acceptable way to do it. This is a multiple-choice question that tests your understanding of how to use scikit-learn's SimpleImputer to fill in missing values in a dataset. Specifically, it focuses on imputing missing ages using the average age. Pretty straightforward, right? I'm testing your ability to use the SimpleImputer class in scikit-learn to replace missing numerical values, represented by nan, which stands for not a number. We'll use the average of the available values to fill in the gaps in the age column of a pandas data frame, which I've called df . You need to choose every code snippet that accomplishes this task correctly. This line, and similar lines in options B, C, and D, shows the beginning of a code snippet. The SimpleImputer class is imported from scikit-learn's impute module. The imp variable is then assigned an instance of the SimpleImputer class. This is the first step in setting up the imputation process. I'm dealing with a common data science problem: missing values. Specifically, I'm using scikit-learn's SimpleImputer to fill in these gaps. This question tests my understanding of how to use SimpleImputer to replace missing age data with the average age from the available data. I'm using SimpleImputer with the strategy set to mean . This tells the SimpleImputer to calculate the average of the non-missing values in the age column and use that average to replace the missing values. The final result is a data frame where the missing age values have been replaced with the calculated mean. The quiz demonstrates that there are multiple ways to achieve the same goal. All the provided code snippets correctly use SimpleImputer to handle missing data by using the mean imputation strategy. The variations are in how they format the input data for SimpleImputer . It's a matter of style and preference, ultimately achieving the same result. Pretty cool, huh? I'm starting with a pandas data frame that has an age column containing some missing values, represented as nan, not a number.